I'm a plant geneticist. I study genes that make plants resistant to disease and tolerant to stress. In recent years, millions of people around the world have come to believe that there's something sinister about genetic modification. Now, genetic modification is not new. Virtually everything we eat has been genetically modified in some manner. Let me give you a few examples. On the left is an image of the ancient ancestor of modern corn. You see a single row of grain that's covered in a hard case. Unless you have a hammer, teosinte isn't good for making tortillas. Now take a look at the ancient ancestor of banana. You can see the large seeds and unappetizing Brussels sprouts, an eggplant, so beautiful. Now, the same month that my laboratory published our discovery on the rice immunity gene, my friend and colleague Dave McKill stopped by my office. He said 70 million rice farmers are having trouble growing rice. That's because their fields are flooded, and these rice farmers are living on less than $2 a day. Although rice grows well in standing water, most rice varieties will die if they're submerged for more than 3 days. Flooding is expected to be increasingly problematic as the climate changes. He told me that his graduate student, Kenong Shu, and himself were studying an ancient variety of rice that had an amazing property. It could withstand 2 weeks of complete submergence. He asked if I would be willing to help them isolate this gene. I said yes. I was very excited because I knew if we were successful, we could potentially help millions of farmers grow rice even when their fields were flooded. Kenong spent 10 years looking for this gene. Then one day he said, "Come look at this experiment. You've got to see it." I went to the greenhouse and I saw that the conventional variety that was flooded for 18 days had died. But the rice variety that we had genetically engineered with a new gene we had discovered called sub1 was alive. On the left, you can see the sub1 variety, and on the right is the conventional variety. Both varieties do very well at first, but then the field is flooded for 17 days. You can see the sub1 variety does great. In fact, it produces 3.5 times more grain than the conventional variety. First, take a look at papaya. It's delicious, right? But now, look at this papaya. This papaya is infected with papaya ring spot virus. In the 1950s, this virus nearly wiped out the entire production of papaya on the island of Oahu in Hawaii. Many people thought that the Hawaiian papaya was doomed. But then, a local Hawaiian, a plant pathologist named Dennis Gonzalez, decided to try to fight this disease using genetic engineering. He took a snippet of viral DNA and he inserted it into the papaya genome. This is kind of like a human getting a vaccination. Now take a look at his field trial. You can see the genetically engineered papaya in the center. It's immune to infection. The conventional papaya around the outside is severely infected with the virus. Dennis's pioneering work is credited with rescuing the papaya industry. Today, 20 years later, there's still no other method to control this disease. There's no organic method, there's no conventional method. 80% of Hawaiian papaya is genetically engineered. Now, some of you may still feel a little queasy about viral genes in your food, but consider this. The genetically engineered papaya carries just a trace amount of the virus. If you bite into an organic or conventional papaya that is infected with the virus, you will be chewing on 10-fold more viral protein. Now take a look at this pest feasting on an eggplant. The brown you see is frass, what comes out the back end of the insect. To control this serious pest, which can devastate the entire eggplant crop in Bangladesh. Bangladeshi farmers spray insecticides 2 to 3 times a week, sometimes twice a day when pest pressure is high. But we know that some insecticides are very harmful to human health, especially when farmers and their families cannot afford proper protection, like these children. In less developed countries, it's estimated that 300,000 people die every year because of insecticide misuse and exposure. Genetically engineered a golden rice to produce beta-carotene, which is the precursor of vitamin A. This is the same pigment that we find in carrots. Researchers estimate that just 1 cup of golden rice per day will save the lives of thousands of children. But golden rice is virulently opposed by activists who are against genetic modification. Just last year, activists invaded and destroyed a field trial in the Philippines. When I heard about the destruction, I wondered if they knew that they were destroying much more than a scientific research project, that they were destroying medicines that children desperately needed to save their sight and their lives.